Greetings everyone, this is Non-Expert here, and today we are going to be talking about the decorator pattern. The decorator pattern comes into structural pattern classification, and the reason why we want to use a decorator pattern is simply because it allows you to add new functionality to an object or a function without actually altering its logic and structure. And it provides you this functionality by creating a wrapper. Now, you'll mostly see a decorator pattern being used in a functional programming paradigm, but it's also been used in object-oriented programming paradigms as well. Now, to better understand why exactly you would want to use a decorator pattern is by actually taking an example. So let's say that you've already built out a website or a web server, and you've built out a front end and a back end, and it seems to be working fine for now. However, you do see that for certain areas, your application doesn't seem to be performing as well as you'd want it to. And what you want to do is you want to investigate and analyze why your app is so. So what you have with you is a classic case of performance issues within an application. However, since you've not added logs, or your logs are not informative enough for you to tell you what exactly is happening, you need to build out some logic in which it will be easier for you to understand why exactly is a function taking so much time. But in order for you to do that, you also need to triage which function is actually taking time. To resolve this issue, what we want to use is a decorator pattern, because what you want to build out is not something that's only straightforward for your implementation, but it's also generic enough that it can be scaled out for multiple other processes as well. So let's take a simple example over here where we've defined a function called as hello, and all it does is that it takes in an argument called as name, and it sleeps for 2 seconds before it prints out a string called as hello and the argument that's been passed to it. So for an example like this, where we're calling the function hello with the argument user, what we'll see is that we can just have a print of what we have so far. So if I execute over here, what you'll notice is that the print is not happening immediately, and that's due to the sleep that we've put. So we want to see how long exactly is this function taking in order for it to execute completely. Now, before we go deeper into actually implementing a decorator, let's try to understand one simple thing. Now, a decorator itself might seem a little bit complicated, but all it's doing is it's wrapping the object or the function that's been provided to it, and it'll execute itself before it executes the actual function. Or it has control over how to go about the execution. So the chain of command is usually that you have the decorator, which is going to be called first, and then whatever's inside of it is going to be called second. With this logic, you can also stack up to multiple decorators as well, but that's a little bit more advanced. So let's take a moment and try to implement our own function or our own decorator, which is going to be used for timing this function. Now, in order for it to actually have the reference, we need to provide it as an argument. So I'm just going to provide it as an argument and just call it as func. Now again, func is just going to be the function which is going to be provided to the decorator, which is the timer. There are also a few other gotchas which people usually face. One of them being that as you're providing the function as an argument, when you go ahead and try to check what exactly is the function name, you might actually lose out on the signature because it's been called by a parent function, which is the timer. So the way to resolve that is actually by using wraps, and there are multiple ways of actually invoking this, but the easiest way is just to call @wraps and then func. Noted that this is also a decorator itself, but this is not a necessary thing for you to actually implement your solution. So the next thing that you want to do is, once you've actually passed in the function or the function's definition, you'd want to have some way in which you can invoke it. And the way we would do that is by actually defining an inner function which can take in all the arguments or the keyword arguments which are going to be provided to the function itself, and basically call that and use that as a reference. So what I'm just going to do is I'm just going to call func with arguments and the keyword arguments which are just going to be passed into the inner function. And eventually what I would want to do is I would just want to return the result. In our case, we're not actually returning anything because we don't have a return, and it will just print out as a none. But a best practice is just to make sure that you're saving that in a variable and just passing that through. And eventually what we would want to do is we would want to return the inner function as well. So what's going to happen is that the way the function invocation is going to work is that we're going to be calling timer, And then within timer, what we're going to be calling is the hello function, and then whatever arguments that need to be provided to it. So once that happens, what's going to happen is that it's just going to try to return this inner function. The inner function is going to be called with the arguments which have been provided, and then those arguments are then going to be used by the function arguments which has been already saved as a state within our main function. A little bit complicated, and it does follow a few other practices which are very common in JavaScript as well. However, we're not going to go into that for now. So for our case, we again just want to see how long is the function actually taking. So what we can do is we can make a new variable and instantiate it by using the current time reference that we have, and do the same thing once the execution is actually finished. So what I'm doing is I'm just saying save the variable called start time when we call the function, and then call another function or a variable called as end time, which is going to save the instance or the time that we have right now after the function has been executed. And eventually what I would want to do is I just want to check how much time it actually took. So when I do end time minus start time, what's eventually going to print out is the number of seconds is actually taken. So to use this, it's pretty simple. Let's just execute this over here and go down a little bit and try to call this function the way you'd want to call it. So what I'm going to do is I'm just going to call the timer decorator, pass in the hello function, which we've already defined over here, and pass it the arguments which are required. So for us, we're just going to pass in user like we did before and try to execute it. Now what you'll see is that we are returning the result, and what's happening is that the function is actually getting executed first. And once the execution actually happens of the hello function, we actually just printing out the amount of time it's taken for it to execute. And we do know for a fact that it's at least going to take 2 seconds because we put in a timer or sleep inside of it. However, we can see like it's not taking that much time. So to resolve this issue, all we'll have to do is just remove the timer. One other way in which you should actually execute this is that you'd want to pass it in as a decorator like I'm doing over here. Now, if I say @timer, essentially it's doing exactly the same thing that we've done in cell number 4. However, it's a lot more cleaner and it's a lot more easier to like just make sure that it's, you know, usable by other functions as well. So I don't have to go ahead and keep on defining it wherever I have to. So if I just say @timer hello and then execute the function over here, or if I just go ahead and run the second cell, which is this guy, you'll be able to see the result that we're going to be printing out with the function itself, and also the amount of time it took to actually execute it. And that's basically it. So that's how our decorator actually works. And usually whenever you come across decorators, there might be a lot more complex operations where you can have a decorator within the decorator. And the way to do that is by actually just adding @timer and then another decorator, and the sequence of operations would be that this would be called first and then the thing below it. However, it's actually really important to just understand that all you're doing is just wrapping the object in such a way that you can just execute something before that, or have control over how you would want the execution to work. One of the most important cases where I've seen decorators, except for just timer functions, is that I've seen it used a lot for context management, which mostly happens whenever you have to like switch out cursor objects or something like that, which usually get missed out whenever you have like debug operations. Additionally, you can also use this for just identifying what exactly is happening, logging, exception handling, and so on and so forth. So moving on, let's try to understand what are the pros and cons of like actually using a decorator or a decorator pattern. So as a pro, as you could see, we were able to easily add or even remove responsibilities from an object or a function pretty easily, and also do it at runtime. You can also combine several behaviors by wrapping objects one after the other, and that will just stack up as you would go about it. And mostly Python or any other programming language would make it a lot more convenient for you to just make sure that you just have to write one-liner to make sure the decorator is actually decorating. Additionally, we are also following the single responsibility principle, which means that you can divide a big class which has a bunch of implementations into multiple possible variants of several smaller classes. Now, one big problem about decorators is that most people don't really understand how decorators work, and it becomes a little bit more complicated for them to actually implement it. So people usually shun that idea of using it, but that's never a good excuse. Also, it's hard to remove a specific wrapper from a wrapper's stack because it's going to be a little bit difficult for you to like debug what exactly is happening. So if you have a bunch of decorators, that might be a little bit of an overkill as well. Also, it's a little hard to implement a decorator in such a way in which it's sort of dependent or needs to identify what exactly is happening before it and after it, because you're not containing that information in any way. Apart from that, decorators are actually extensively used, and either if you go into the Python domain and if you're using web frameworks like Flask, you'll mostly be encountering or making functions or routes by using decorators themselves. So it's a pretty useful concept and it's pretty handy in the production quality code as well. With that, that was all, folks. It was amazing to have you with me today. I apologize for not uploading more frequently. However, if you did like this video, do give a like and do leave a comment if you didn't understand something. Also consider subscribing because we are discussion over here and we would love to have you on board with us. Thank you and have a nice day.